Hello and welcome back to Tech and EduSpark Hub, where technology meets education. Today we'll be beginning with our EduSpark series, and in today's lesson we'll be looking at pressure. So under this pressure, we'll be looking at two concepts, and the first concept is pressure in a solid, and the second concept is pressure in a fluid. And you know fluid can contain gases or liquids. So we'll be looking at pressure in a fluid and pressure in a solid. From the definition of pressure in a solid, pressure can be defined as force per unit area exerted on a surface. So mathematically, pressure, which is P, is denoted as force, which is F, per unit area of a surface. So this F is standing for force, and this A is standing for area. And this is the mathematical representation of pressure in a solid. And we know that the force, which is measured in Newton, with the area, which is measured in meter square. So looking at this pressure, the SI unit for pressure is given as P equals to Newton per meter square. So this is the SI unit of pressure. And on the other hand, we have another SI unit of pressure, which is in Pascal. So we have the Pascal. So pressure can be measured in Newton per meter square or in Pascal. So it is either one of the two. And we have some other unit of pressure, which are the torr, the bar, and so on. Without wasting much of our time, let's look at some examples under the pressure in a solid. Example 1 as projected on the screen. The question says a solid metal exerts a force of 600 Newton on the ground. If the area of contact between the block and the ground is 0.3 meters square, what is the pressure exerted on the ground? So from this question, you can see we have the force given. So the force, which is the F, is given as 600 Newton. And on the other hand, we have the area, which is the A. The area is given as 0.3 meters square. And they ask us to calculate the pressure, which is P. So when you have any type of question, the first thing to do is to write the given parameters in the question. And once you have the parameters, you can be able to solve the question with ease. So in this case, since we know that the formula for our pressure, which is P, is equal to force over area, and we know that our force in this case, which is given as 600 Newton, so we can say 600 Newton divided by, and our area, which is A, is given as 0.3 meters square. So in this case, when you press 600 divided by 0.3 in your calculator, you should have your P to be 2000 Newton per meter square or 2000 Pascal. So either one of the two, you have your correct answer to this type of question. Now, let's look at another example under the pressure in a solid. The question as projected on the screen says the area of the effort and load piston of a hydraulic press are 0.5 meters square and 5 meters square respectively. If a force F1 of 100 Newton is applied on the effort piston, the force F2 of the load is. So in this type of question, you can see we have two area and two forces. So let's write the given parameters. So in this case, we have the area 1, which is equal to 0.5 meters square. And on the other hand, we have the second area, which is area 2, which is equal to 5 meters square. So now, on the other hand, we have another force, which is F1. So the F1 is equal to 100 Newton. And we have F2, which is what we are looking for in this question. Going back to our formula of pressure, we have that pressure is equals to force over area. So if we have the pressure to be equals to force over area, so we can say this is our force pressure, which is F1 over A1. And secondly, we can equate it to another force over area, which this will be equal to F2 and A2. So we have our F1, A1, F2, and A2. So in this case, this is the first pressure and this is the second pressure, and we can equate the two pressure together. So putting our parameters in the formula, we have our F1, which is 100 Newton, divided by our A1, which is 0.5 meters square, and we equate it to the F2, which is what we are looking for in this case, divided by our A2, which is 5 meter square in this case. Notice that the parameter is in meter square, so we don't need any conversion to this type of question. Assuming you have centimeter square, you have to convert to get the meter square because the meter square is the standard unit of area. So in this case, you can just cross multiply. So this F2 will multiply by 0.5 and we will equate it to this 100 multiplied by 5. And in this case, we have F2, making F2 the subject of the formula. So this multiplication will turn to division on getting to this side. So we have F2 is equal to 100 times 5 divided by 0.5. And in this case, our F2 will be equal to 500 divided by 0.5. And our F2 in this case will be equals to 1000. So don't forget the unit of force, which is in Newton. And this is our final answer to this type of question. Up next, we'll be looking at the pressure in a fluid. And like I said earlier, a fluid can contain a liquid or gases. And the pressure in a fluid is different from the pressure in a solid. So the formula for pressure in a fluid is given as P, which is the pressure, is equal to the density multiplied by the gravity multiplied by the height. So you can say P is equal to the D multiplied by the G multiplied by the H. So this D is standing for density, this G is standing for gravity, and the H is standing for the height. But some will be wondering, how do we derive this formula, which is P equals to density times gravity times height? So remember, from the formula of pressure in a solid, we have P to be equals to the force, which is F over area. And from our formula of force, we have F is equals to mass times acceleration or mass times gravity. So we'll be using mass times gravity in this case. And we can bring back the formula for F to this formula for pressure. So we can say P is equals to the mass times gravity divided by A. So what we do here is just that we bring the formula for this force, which is mass times gravity, to this formula in pressure, and we have the P, which is pressure, equals to the mass times gravity divided by the area. And also remember, from density, we have the formula for density, which is equal to D. So we have D is equals to mass over volume, and this is the formula for density. And since we have the mass here and we have the mass here, we can make the mass the subject of the formula in this density. And making the mass the subject of the formula, we have the M is equal to this, we multiply this D times V. So now that we have the mass as the subject of the formula, we can put the mass in this density to this pressure. So we can say the pressure, which is P, is equal to this mass. And in this case, this mass will be equal to the density times volume. So we have the density times volume times this G divided by the area, which is the A that is under this pressure. So now that we have the formula density times volume times gravity divided by area, and we know that the formula for V, which is the volume, is equal to length times breadth times height. So this is the formula for volume, and we know that the length times breadth is equals to V equals to A multiplied by the H, which is the height. So this length times breadth is the formula for the area, and we can put this in this formula for pressure. So now that we know that V is equal to A times H, we can say pressure, which is P, is equal to density times this V. So this V in this case will be equals to A multiplied by H multiplied by the G that we have here divided by the area. So now that we have this, the area down can cancel the area off. So we have our formula for pressure in a fluid to be given as density times height times gravity. And that is how we get the formula that we have initially, which is the density multiplied by the gravity multiplied by the height. So you don't need this derivation. I'm just deriving this formula, so you won't be lost how we derive the formula for pressure in a fluid, which is given as P equals to the density times gravity times height. So this is the formula that you need. So you don't need all this derivation. This derivation is just to show you how we come across this formula that we derive for pressure in a fluid. Now, let's look at some practical examples under the pressure in a fluid. The first example we have says that what is the length of the liquid column in a barometer tube that will support an atmospheric pressure of 102,000 Newton per meter square if the density of the liquid is 2,600 kilogram per meter cube, and they give us gravity, which is G, to be 10 meter per second square. So like I said earlier, whenever we are given a question, the first thing to do is to write the parameters. And in this case, our first parameters, which is the pressure, is denoted as P. So we have P is equal to 102,000 Newton per meter square. And secondly, we have the density, which is D, is equal to 2,600 kilogram per meter cube. And lastly, we have the G, which is equal to 10 meter per second square. And what are we looking for in this question? The question is asking what is the length of the liquid column in the barometer. So the length, so we can denote length as the height. So the height is equal to unknown. So this height is the same thing as the length. So remember from the formula for our pressure in a fluid, which is P equals to density times gravity times height. So we can come back to our formula, which is P is equal to density times gravity times height. So our P in this case is 102,000 Newton per meter square is equal to our density, which is 2,600, multiplied by our gravity, which is 10, and multiplied by our height. And that is what we are looking for in this question. So now we can make the height the subject of the formula. So to make the height the subject of the formula, we can say the height is equal to this 102,000 divided by everything that is here. So we have that 2,600 multiplied by 10. So in this case, we have the height is equal to 102,000 divided by 2, 6, 1, 2, 3. So in this case, this will cancel this, this will cancel this, this will cancel this. So we have our height is equal to, so when you press this in your calculator, we have our height to be 3.92 meter. And this is our final answer to a question of this type. Let's look at our second example under the pressure in a fluid. The question says the normal atmospheric pressure at sea level is 105 Newton per meter square, and the acceleration due to gravity is approximately 10 meter per second square. If the atmosphere has a uniform density of 1 kilogram per meter cube, its height is. So in this question, let's write the parameter that we are given. So from the parameter, we were given the pressure, which is P, to be equal to 105 Newton per meter square. And we were given the acceleration due to gravity, which is G, to be equal to 10 meter per second square. And lastly, we were given the density, which is D, to be equal to 1 kilogram per meter cube. And this case, the question is asking about the height, which is H. So, and remember from the formula for the pressure in a fluid, we have P is equal to the density times gravity times height. So substituting our parameters in this formula, we have our P to be equal to, what's our density? So we have the 1 times, what's our gravity? So the gravity here is 10 meter per second square. And lastly, we have the height, which is unknown. So we can put our pressure, which is 105, equals to 1 multiplied by 10 multiplied by the H. So in this case, we have that 105 is equal to 10 multiplied by H. And to get our height, we can make the height the subject of the formula. And to make the height the subject of the formula, we have that H is equal to 105 divided by 10. And in this case, our H, which is the height, will be equal to 10.5 meter. And that is our final answer to questions like this. And that will be all on pressure in solid and pressure in a fluid. Attempt this question on the screen and let me know your answer in the comments. And if you found this video helpful, don't forget to give it a thumbs up. Subscribe to Tech and EduSpark Hub for more tech contents and educational school lessons. And in our next lesson, we'll be diving more deeper into pressure in a barometer. And until then, keep learning, keep sparking, and I will see you in the next one.